value, or the retention factor. Now the RF value is calculated by the distance the ink moved divided by the distance solvent moved. I'll show you how to calculate it for this green dot here. So I'm going to measure from the pencil line here. The ink moved, I'm going to go to the middle of the ink blob. It moved 3.5 centimetres. So I'm going to do 3.5 divided by the distance the solvent moved. I'm going to measure from the pencil line where it all started up to where the solvent front got to, which is 4.7 centimetres. So I would do 3.5 divided by 4.7. I haven't got a calculator, so then you'd find your answer, and that would give you your RF value. You get marks just for writing out the formula and using those numbers, so it's worthwhile doing that even if you don't have a calculator. The final thing you need to know is how to separate particles out of drinking water and make it safe to drink. So here we have our water coming in from our source. It could be a lake, it could be a river, it could be a reservoir. Point is, it's going to have twigs, leaves, that stuff's called debris. You obviously don't want that in at the end. It's then got some small insoluble particles in it as well, such as dirt, soil, things like that. It's also got microorganisms such as bacteria, and it will have some soluble salts as well. The first stage is called sedimentation, and it happens in a sedimentation tank. So the water comes in from the source. In the sedimentation tank, the sediment or the large debris particles fall to the bottom of the sedimentation tank. So the debris falls to the bottom and sits at the bottom. So only the water can go through to the next stage. The next stage is called filtration, and this has layers of larger particles to filter the water. So the water trickles through these layers of sand and gravel. Gravel's obviously larger particles than sand, and only now the tiniest microscopic particles can get through. All of the other insoluble particles are filtered out. So insoluble particles removed here. Now, all that's left, we've removed our debris during sedimentation, we've removed the insoluble particles during filtration, we've got some microorganisms. So step number 3 is chlorination. This is where you add chlorine, just like you do to a swimming pool, but not as much, and this kills bacteria and other microorganisms. Now we've got safe drinking water. However, our drinking water does still contain some soluble salts. It's fine, but if you want to do chemical analysis with them, you need to remove those by distilling the water so that they don't react with anything that you might be testing with. That's everything you need to know. Thank you for listening.